guys. So we had a really good question yesterday on the Facebook Live about how long you could stay down. We were doing the Facebook Live about the Meg ledge, how long you could stay down looking for teeth without going into decompression. And I thought this was a great time to touch up real quick on a really handy tool that you can use with just your recreational dive planner, air tables, but by using nitrox. And so what we do for that in that case is we use what's called the equivalent air depth to run nitrox on a regular air table. And so what you're doing is you're basically engineering the nitrogen load for the equivalent air depth. So even though you're using nitrox, you're getting the benefit of a shallower depth because you're using the extra oxygen is displacing some of that nitrogen. And so here is the equation to plan that out. It's just simple math. And so we're going to use it. I'm going to show you guys exactly how it works here. So here's a recreational dive planner. And we know that we're going to go to 100 feet. So that's right here, 100 feet. So what we need to do is find out what the equivalent air depth would be based on the nitrox mix that we're using. So in this case, 32% is the most common. And so what you're going to do is you're going to do 1 minus the fraction. FO2 stands for fraction of oxygen. In this case, it's going to be 0.32 times the depth that we know is going to be 100 feet plus 33 divided by 0.79. So I'll do this real quick. Divided by 0.79. And then at the end, we need to take the result and take 33 off of it for the atmosphere, the top atmosphere. So doing this math, we're going to do 1 minus 0.32 is 0.68. 0.68 times 100 plus 33. Everybody should be able to do that math pretty easily in their head. And we'll do 1.68 times 133 is 90.44. And then we're going to divide that by 0.79. Gives us 114.48. And then we're going to take 33 feet off of that. So minus 33 gives us 81 and some change, 81.4. So we're going to base our dive, even though we're diving at 100 feet of depth, if we run our table for air using that nitrox mix of 32%, you're going to plan it as though it would be an 81-foot dive on an air table. And so when we plan like that, we would come back, if you remember, anything over the solid, the whole number is going to be the next depth. So even though it's 81, it's going to be, we're going to roll that up to 90. So we're going to plan it as a 90-foot dive. And then all the way down, you follow it all the way down, you can see you get about 24 minutes. 25 minutes is going to be the no decompression limit. So if you're at 25, you're right there. So we usually plan on 24 minutes. Good rule of thumb on the Meg ledge is that if you are getting pretty close to your NDL, give yourself 2 or 3 minutes to swim back to the line and start your way up, because your NDL is not going to start going back up until you start your ascent. And we don't start that ascent until we actually hit the line going back up to the boat. So as you swim back along your reel, you're still at that depth and you're still accumulating nitrogen. You're still going to be running that NDL clock, but as soon as you start your way up on the boat line is when that NDL starts to go down. So you can plan with 32% on the Meg ledge at 100 feet with 32%, 24, 25 minutes. Now that's going to go down on second and third dives, subsequent dives. Also keep in mind that This is based on a square profile. So this is one of the dives where you can really truly plan out your dive based on a table, because you're going straight to the bottom, you're searching for teeth the entire time, and then you're coming back up. It's not like a wreck where you're going to have a lot of relief up and down, or a reef somewhere where you'll be changing depths often. So that's how we can plan that out. And then something else that is a good tool to have to be able to work for the Meg Ledge is your surface air consumption rate. Because you are at 100 feet, calculating your SAC is kind of important. It'll give you a really good idea of being able to plan how much gas you need to be able to actually meet that NDL. So in the case that we were just talking with 32%, that NDL is 25 minutes. Well, if your tank volume doesn't have enough gas to last you that 25 minutes, you're really not getting the benefit of the nitrox if you have to come up, because your pressure is going to be low before you need to. And so what we do to figure that out is we need to find out how many atmospheres that 100 feet is. So we do 100 feet divided by 33, and then plus 1 for the top atmosphere. So it's 100 divided by 33 plus 1 is 4.03. So we're at 4.03 atmospheres at 100 feet. And then to do a SAC rate calculation, it's probably a little bit outside of what the video here is meant to be. I can do another video on that. And basically, you're going to do some math based on a couple figures that you're going to get on an actual dive. So easiest way to do it is to go into the water, go down to 33 feet, or any known depth. You can do the math however you want, but go down to a depth. Try to maintain that depth for the entire time that you're calculating. You want to take a start pressure, swim for about 10 minutes, and then take an end pressure. But during that 10-minute swim, you want to keep it as constant of a depth as you can, because that makes the math more accurate. At the end of that, after you do the math, you're going to have how much cubic feet per minute of gas you use, what we call SAC, so surface air consumption rate. So for instance, on open circuit, mine is 0.5 cubic feet per minute. So 0.5 cubic feet per minute, let's see here, is what I do. So what we do is that's what I would breathe at the surface, and we're going to calculate, we're going to multiply that by how many atmospheres we are diving. So we'll go back here, 0.5 times 4.03, so about 2.01 cubic feet per minute for diving. Now that's a relatively relaxed, steady pace dive. If you're going to be working hard, like in the megalodon tooth instance, you might actually increase that a little bit. So a good rule of thumb would increase your SAC rate calculation by a little bit, so maybe even go up to 0.8 on this. And that's what we'll do here for this math calculation here. So that's giving you a lot of conservatism. So 0.8 times 2.01. I'm sorry, that's not what we're doing, because this is based on the SAC rate there. So we're going to do 0.8 times 4.03 atmospheres, and you can calculate 3.2 cubic feet a minute of gas needed. And then you can figure out if you're going to do we said 24 minutes was the NDL that you could do based on 32% nitrox. You could do 3.2 cubic feet per minute times 24 minutes. And we'll do that. And so you can see on that dive, just in bottom time, you're going to be using 77 cubic feet of gas. Now, keep in mind that an aluminum 80, that would leave you with 0 reserve. You'd be coming up on the boat with just a couple hundred PSI on your tank. So aluminum 80 is not going to be your best option in this dive. I would say a steel 100 would be okay, a steel 120 even better. Steel 120 is going to give you plenty of reserve on the way up. If you run into a problem and actually dip into some deco, you'll have enough gas to get you through your deco stops. So steel 120 would probably be the best bet on this. dive here. So that's two different planning things we can use, is the equivalent air depth calculation and then the SAC rate calculation to give you some planning for the MIG ledge. If there's any other questions, please let me know. I'd be happy to show you. Other than that, we'll see you on the next Facebook Live.